All right, let's look at the homework 3.6, problem number 8. All right, let's evaluate these limit at infinity. All right, let's do that. All right, so let's look at the first one. All right, so we have limit as x approaches infinity of this rational function here. All right, so as x goes to infinity, you can see that the numerator goes to negative infinity and the denominator goes to positive infinity. So you basically have an infinity over infinity situation. So we have to do some work, right? So what you do is I'm going to look for the highest power on the denominator. You see that there's x cubed here. So what I'm going to do is I'm going to divide the top and bottom by x cubed. So I'm going to put, let's say, a fraction here, and I'm going to put 1 over x cubed here. Right? Oh, maybe that looks kind of bad. Maybe I'll do this. Right? So I'm going to put 1 over x cubed. How about that? Right? So I'm going to multiply top and bottom by 1 over x cubed. So you're going to have something like this, 1 over x cubed, right? Again, the way I chose this is you look for the highest power here. So it's cubic power is the highest one. So I'm going to divide by x cubed, right? So we're going to do the top and bottom that way. All right, so this is going to give you, so this is equal to, we still have the limit, so we leave the limit for now, right? So we have limit there, right? So let's multiply, right? We're going to distribute the 1 over x cubed to 5, so it's going to be 5 over x cubed. So that's going to be on top, right? So it's going to be a fraction, and you're going to have 5 over x cubed. So we get that. Right? Next term is negative 9x. So one of the x's cancel out. So you're going to get x squared on the bottom. So you're going to have minus fraction 9 over x squared. Right? So you see that, so if you distribute 1 over x cubed to these two terms, we're going to get these two terms. Right? We're going to do the same thing. So 4x cubed times 1 over x cubed. So x cubed cancel out. So you're just going to get 4 on the bottom. Right? And then 1 times 1 over x cubed, it's 1 over x cubed. So we're going to add 1 over x cubed. Right? So we get that. Right? So you can see that here, as x approaches 0, right, this term is going to go to 0 because you have 5 divided by extremely big number, right? Same thing here, 9 over really big number, right, goes to 0. And then this one goes to 0. So maybe I should write that, right? So I'm saying that you're going to have a, let's see, I have to write it this way. So this is going to be 0. Hopefully this will work. I'm going to, so we know that here, right? So this guy goes to 0, right? And also, right? So it takes a little bit of typing here, right? So we know that this guy also goes to 0, right? And the last one is 1 over x cubed also goes to 0. So we have, let's see, hopefully this will get there. All right, so we have that. All right, as you can see that the numerator is going to go to 0, right? So we're going to have 0 on top, right? And the denominator is going to be 4 plus 0. So you're going to get 4 on the bottom. But that's a long way of saying 0, right? So it's going to be 0. All right, so part A, it goes to, the limit is 0. All right, so let's type it in. All All right, answer is going to be 0. All right, let's check the answer here. All right, I came back and looks like we got part A correctly. All right, so let's look at part B. All right, here's a part B. Strategy is exactly the same. You look for the highest power, so it's first power is the highest power. So what we're going to do is we're going to divide top and bottom by x. So you're going to have multiply by 1 over x on top and multiply by 1 over x on the bottom. So it's going to look something like this. Let's see. Takes a while to type that out. All right, so we have that. So this is equal to, all right, so we still have, we haven't evaluated the limit yet, so I still have to have a limit in there. All right, then here, we're going to just distribute 1 over x to 5 and negative 9x. You're going to get this. So let's see, 5 times 1 over x is going to be 5 over x, right? So we have 5 over x, like that. All right, then here, if you distribute 1 over x to negative 9x, so x cancels out. So you have just a negative minus 9. So I put the minus 9 there. All right, so that's the numerator. Denominator, so 4x times 1 over x is going to be just 4 because x cancels out. All right, then if you distribute 1 over x to 1, you get 1 over x. So you're going to get just 1 over x. All right, so we get that. All right, then you can see that the 5 over x goes to 0. So I'm going to say, let's see, we are going to, this is going to 0, right? So I'm going to take a little bit of typing here. So this guy goes to 0. And also 1 over x goes to 0. So I'm going to just say, let's see, it is going to 0. All right, so we got that. All right, then you can see that what's left is negative 9 on top and a positive 4 on the bottom. So answer is negative 9 over 4. All right, so that is the limit. All right, so let's type it in. All right, so we got the answer to be negative 9 over 4. All right, let's check the answer. All right, I came back and looks like we got the part B correctly as well. All right, so let's do the last part, part C. All right, so again, strategy is the same. We're gonna, let's see, so highest power is 1. So I'm gonna divide the numerator and the denominator by x, just like before. So let's put that in there. All right, so we're gonna have here. All right, we do that, right? So it's gonna be equal to. So we're gonna still have to have a limit still. So we have a limit there. All right, so distribute, so you're going to get on top, you're going to get 5 times 1 over x, so it's going to be, you're going to have a 5 over x, right? So we're going to put 5 over x, put that in there. All right, so if you divide this guy by x, so 1 of the x cancel out, so you're going to get the negative 9x on top. So negative 9x on top, all right? The denominator, 4x divided by x, you're going to get 4. So we put 4 in there. All right, then 1 times 1 over x is still 1 over x. So plus 1 over x. All right, so we get that. All right, as usual, as x goes to infinity, 5 over x goes to 0. So let's put that in. All right. It's going to 0. Make sure that I put it in the right place. So we have, oops, that. All right, and also 1 over x goes to 0. So I'm going to send that to 0. So, all right, then let's see, we have that. right? Oops, I made a mistake here. Let's see, it's just a little typo there. All right, so we have that. All right, then what happens is x is going to infinity, right? So you have a -9 times infinity. So -9 is actually, negative 9x is actually going to negative infinity, right? So you have, right, negative infinity. So I'm going to just do that. Let's see what it looks like here. All right. So this guy actually looks kind of weird. Maybe I'm going to fix that a little bit here. All right. So we know that here. All right. So that term, negative 9x, is going to negative infinity. All right. So what you have is a negative infinity on top divided by 4 is still negative infinity. So this is equal to negative infinity. All right. So let's type that answer in. All right, and here, so limit does not exist, but the reason why it does not exist is that it goes to negative infinity. All right, so let's check the answer. All right, I came back and looks like we got the part C correctly as well. All right, that's it. I hope that this was clear.